Hello, everyone, and welcome to week 9 of an introduction to agent-based modeling. And so week 9 is chapter 7, unit 7, which is verification, validation, and replication. And this is actually a week that I take a lot of personal interest in. I've written several papers on this topic, on these topics, I should say. And I think it's also come up a bunch in the various office hours and on the discussion boards. So just quick summary at the very top so you know what you're getting into when you start this unit, right? Verification is making sure that your conceptual model, right, the model you have conceived of in your brain and talked about with subject matter experts, matches the model that you're actually implementing, the agent-based programming code itself, right? And of course, there's a lot of standard ways of doing that you probably have thought about in the past, like documentation of both the conceptual model and the implemented model. But we'll go into some other methods as well during this class. This second concept, validation, is about making sure that your implemented model matches the real world in some meaningful way. And there's been a bunch of questions about that on the forum, and there are many, many solutions to that. But I present a couple of them in the description in the unit that we're going to go through. Okay, and then finally, replication. So replication is the idea that a new group of scientists, right, or even the same scientists, builds the same model, the same conceptual model, in a different language, on a different platform, in a different space, right? Replication is a vital concept in science in general, right? Like the idea that if I can repeat my findings, that means that something about them is fundamentally more likely to be true, right? And so I highly encourage replication. Replication also aids in both verification and validation, right? Because you can't do replication without making sure that the published version of the model is an accurate account of the implemented model, right? Moreover, it aids in validation because unless you're just like a blind automaton going about implementing the conceptual model, you have to question the assumptions of the original conceptual model when implementing it, right? And so I highly recommend, kind of going through the unit materials and discussing and understanding what verification, validation, and replication mean and how to employ them, okay? So that's the big kind of overview for Unit 7. Now, the peer review deadline just passed for the model design documents. And the next assignment's coming up already, right? Your final assignment in this class, right, is due on August 13th. So it's coming up rather quickly. I made a small typo in my email last night saying that the final assignment would be posted this week. In fact, it was already posted last week. I thought it was in Unit 7.1, but it was in Unit 6.6. So it was already posted. So you should be able to see it out there already. And you should have been able to see it for about a week or so. And so if you have any questions finding that or understanding what it's talking about, please post them on the forum, right? And of course, that's the reason why that's due on August 13th, even though the class doesn't end until the end of August, is because we need 2 weeks for the peer review to do, right? Now, the way you're graded on the final assignment, so I can't ask, a random person in the class, right, who's educated in agent-based modeling, but maybe not educated in your field, to judge whether or not your model is doing a good job. So instead, what I'm asking you to do is really pay attention to the info tab of your model, right? And make sure that you've documented well what you want the model to do, right? And then what the peer reviewer is going to grade is whether or not the model matches up with what the info tab says it should do. Now, one small note, and I'm going to add a little bit of a clarification, especially on this final model assignment, right? It is not in the spirit of the class to just simply take a model from the models library and turn that in as your final model, right? So what I would ask the reviewers to do, even though there's not specific instructions to this in the assignment, is any model you're given, take a couple of the keywords and just search the models library to see if they're there, right? And if they are, let us know, right? That's, like I said, that's not in the spirit of the class, right? The spirit of the class is that you're going to either take a model from the models library and modify it substantially to achieve some new goal, or you're going to design your own model from the ground up and implement all the aspects of it along the way, right? And the reason why I don't say just design a model from the ground up is often some of the best models are actually models that are dramatic modifications to already existing models, right? And so I don't think it would be fair to ask you that the model has to be completely original. In fact, it's in the spirit of agent-based modeling and programming in general to copy code and give attribution to the original code that it's copied from. Okay? So that's it for the final assignment. I have a bunch of questions that have come up over the last week, and so I'm going to try and get through as many of them as I can. But let me check quickly just to see if there's any questions on the YouTube channel or coming through on Twitter. Right? Nothing yet on YouTube and on Twitter. Let's see. Oh, I didn't actually have my Twitter client up and running yet. So take a second longer, but there it comes. Okay. Doesn't look like much. By the way, if you are interested in following agent-based modeling work in general post the class, I have control of the intro to ABM account even when the class is not in this session, and so I will tweet out interesting ABMs I see or interesting tweets I see about agent-based modeling during the whole year. You can follow that account at twitter.com/INTRO, the number 2, the letters ABM, right? Intro to ABM, okay? And of course, you can always follow me at Bill Rand on Twitter. Easy to find, both the same as my YouTube handle, right? Okay, so that's what we've seen so far. Let me go through a couple of the questions then that have come up over the class. So one question that came up that we talked about a little bit in last week's class was this idea of how to create geographic boundaries within the patch-based world, right? And what I showed last time was an example of how to do columns, for instance, right? And that seemed to work pretty well. But there was a question, somebody in particular really liked the Voronoi example in NetLogo, and so they wanted me to talk a little bit about that. So let me pull up the Voronoi example. Let me set up my NetLogo window. Okay. Oh, not that one. There we go. Okay. Let me make it a little bit bigger. Turn off my face. You don't need that while I'm doing this. Okay. So, by the way, a small little trick for those that's undocumented in NetLogo is that if you type 3 underscores into the observer and then type the name of a model that you want, it'll automatically load that model. The reason why I'm doing it is partially because otherwise it's not going to show you the windows. So it's undocumented, hidden feature, developer only kind of feature. Okay, so so now we have the Voronoi model set up. So let's just look to see what it does first of all, right? You can see when I hit setup, it just kind of creates this nice patched world. And if I hit go, I can grab one of these points and drag it, and the patches change. So what is actually going on? Well, let's look at the documentation tab, right? So the model draws a Voronoi diagram of polygons around a set of points. So actually, the only thing that's defined in this model is the points. The Voronoi diagrams, basically what they are is they're coloring each point in the model based upon the closest point to it, right? Let's see if it's, where does it say this? Doesn't, that's interesting. So actually we probably have to go into Wikipedia to show you a definition, but basically what this is saying is any purple point, for instance, is closer to this point than it is to any other point in the model, right? And so you get these interesting shapes, right? So, for instance, this point is all the way, there's this blue point that you see, right, kind of in the middle, don't actually see my cursor when I'm doing that, so it's a little weird. Wonder if I can click on it. Yeah, so this point, right, like that I'm moving now, right? So that point, if I put it right there, it's interesting because it's really close to this point, right? But it's these points in the world are still closer to this point than they are to this point, right? And all of the points over here are still closer to this point than they are to the purple point, right? And so it's an interesting way to draw diagrams. Basically, you can plop down the centers of your world wherever you want, and it will automatically figure out what point is closest to it. So how does it actually do that? Well, let's look at the code, right? Let me blow it up a little bit, make it a little bigger for you. So basically, there are points, right? And then there are two additional breeds. There are spawners and updaters, right? And the setup code is like is the main code. And basically, what it does is it looks at a bunch of different colors. So it's kind of interesting. This is kind of just filtering out. So it's going to use colors 13 to 17, 23 to 27, blah, 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 103 to 137, just to get colors that are in a range that are easy to distinguish. So it's just going to create a set of available colors. If you come out here, right, it'll show you the available colors, right? And it just basically, if you look at it, what it's doing is it is just taking this C value and mapping it to all these different colors that are out there, right, for 140 different values. So it has 140 colors, right, and mapping them to different values out there, right? Sorry, it's taking a random number from 0 to 140 that's based upon this number slider and then mapping them to all these different colors, right? Okay. And it's saying set default shape to circle 3 for the points, which is the hollow circle. Ask n of number of patches. So this is the number of points we're going to have, right? 40 points. Right? To make a point, and when you make a point, right? All you do is sprout one point, set its size to 5, take the first of the available colors, and then remove that color from the possible list. Right? Actually, I realized I misspoke a little bit. I said that it was going to choose how many colors to make based upon this, but it's actually going to make 140 potential colors. It's just going to be from this particular list, right? So we can take this. We can, if I take n values 140, and I say something like random 10, right? It's going to create 140 random 10. But instead, what it's doing is it's creating 140 values that are a shuffled list. And what does shuffle do? Shuffle is an interesting command in NetLogo. Let me bring that up. One second. There we go. Okay. So shuffle basically reports a new list containing the same items as the input list but in a randomized order. So essentially, what's happening here, right, is, let's get rid of that one, is that we're creating a whole bunch of numbers that are in the range 13 to 17, 23, 27, et cetera, but then we just randomly shuffle them. So now we have different colors, right, in different order. But we have 140 of those colors, right? And by the way, 140 is well below the max of the number of possible points, right? So it's deliberately set up to be about half of it. Okay. So now we have our points, we have our colors, right? Now we have to recolor the patches. So if we, let's see, one thing you can always do if you want to see what code does, right? You can write setup, and I put a stop in there, right? This is a little bit of a debugging trick. I put a stop in there, which is going to stop the code from continuing to run. So I can see what happens if I just run that code, right? And as you can see, if I just run the code up until that point, I just get those different points in that spaces, right? So then the big thing that comes along is the recolor code. What does recolor do? So recolor And this was inside an ask patches, by the way, just so you remember, right? Ask patches recolor. So recolor sets the patch color of whatever patch we are to the color of the min one of the points distance to myself. So min one of, right, takes a agent set and a reporter and reports the thing that has the minimum of that reporter, right? So what's the reporter? The reporter is distance to myself. So this is the distance to the patch from the point. In NetLogo, self is always referring to the agent that is currently executing. Myself, and it's kind of a little complicated, but myself refers to the agent that called that agent, right? This has been hotly debated, within the NetLogo development community for a while as to what this should actually be, right? But right now, it's been myself and self for a while, and so let's just leave it at that, right? So myself is the agent who called this. So distance is being executed by all the points, right? But myself is actually the patch that's calling that, right? And so this is calculating the distance between that patch and all of the points, and then min one of is returning the minimum point to that patch. And then color is just saying we're going to set the p color of this patch to the color of that particular point. Okay, and that's all the code does, really, right? So when we set it up, it's just you're seeing it when it goes through. Just kind of update all of that, right? So if we slow down the speed, well, let's actually, let's hit setup, right? You can see all the points coming into being, and now you can see patches randomly deciding, or random order of patches deciding which point they are closest to, and then changing their color to that point, right? So speed this up, all right, we get it out. Okay, so that's the Voronoi model. That's the most important aspect. And then, when the go procedure is done, all it's doing is looking for the mouse, right? Obey mouse. And this is just checking to see where the mouse is. There's some standard code. If you ever want to have a model that you can interact with on the graphics window, this is a good code to look at because it kind of helps you do that. And then it's going to, once it does that, it's going to ask the spawners to spawn, which basically just says, patch some updaters who are then going to go out and figure out which of the different patches need the update, right? And then it's going to recolor those patches. Okay, so this prevents it, so you don't have to. The other way to do this would be to recolor all the patches every single time you move a point, right? And this helps you by only recoloring those patches that should be affected by the move. Okay. So that's the Voronoi model in all its glory. Hopefully that's helpful for some of you and can help you out a little bit. Okay, so let's see. Switching over a little bit. Let me switch back on my laptop camera. So hello again. And let's see. So there was a question that came in on YouTube during the time. From Jorge Martinez. I would like to analyze the difference of two groups over time being active in behavior space measure runs at every step. What analysis do I need to do that for in R? I'd like to analyze the difference of two groups over time being active in behavior space measure runs at every step by analysis. So there's a number of ways. I think I understand what you're asking, Jorge. Sorry, it took me a little time to puzzle through that. I think what you're saying is that say you have two groups, a red group and a blue group in your model, right? Red agents and blue agents. And you have some sort of time series of like income or distance from center or something like that, and you want to analyze that. How do you analyze that? Well, in behavior space, right, you can obviously report whatever those values are, right? So you could port the mean wealth of the red people and the blue people over time, right? And then you could dump that into R, just like we've done in the examples. And then you can essentially run whatever analysis you want between them. The question, I mean, when you say what analysis do I need to do for that in R, it really depends upon what the question you have is. Are you wondering how close they are to each other? There's a number of different things that will help you measure that, right? So you could look at the correlation between the two groups, right? So let me bring up R, right? I won't go through the whole process of creating the model and doing that. Let's assume that based upon the class lectures, you can figure out how to import two data sets into R. But let me show you what you would do once you have that, right? So let me get some. Let's see. I'm just trying to remember exactly how I want to do this. Let me actually just bring up some data real quick. That's probably the easiest way to do that. Okay. Well, here, what I'll do is I will go into the examples that we've been using. Let me see if I can bring it up real quick. Let me find it in the Innovation Diffusion models. Might be useful. Okay. Okay, sorry for the delay on that. Let me see if I can get this pulled up so you can see what I'm looking at now. Yeah. Let's just bring up R. Okay, there we go. And I will turn myself off again. Make R a little bigger. Bring it to the center. Okay. So I'm going to be looking at the disease density data, right? So load up the HMS package. I'm not sure if I'm going to need it for this example. And it's in a slightly different space right now. Well, let's see, where is that? Spread of disease, population, density. Where do I have that file? Is it this one? No, it's not that one. Oh, good. Thought I had it saved. Hold on one second. Oh, here it is. Okay, good. Okay. Okay, so now I've read in that data, right, and I can just look at the data, right, and these are just the commands that are in the basics. So, for instance, let's imagine that, infected and number of people were two different series, right? I obviously, once I have that data in however form I've read it in, right, I can then do things like just run correlation. I'm not sure if that's what you're looking for, right? So I can see, like, what's the correlation between the number of people and the number infected. Oh, might help if I do it. Oh, and I got to give it the right setup. So with data, right? So in this case, right, the number of people is 0, right? So that's preventing me from doing any kind of interesting analysis on it. Let's see. I could look at the difference between the number of people, the number infected, and the ticks, for instance, right? Again, the standard deviation is 0. Why is it? So in this data, is the number infected not change? Yeah, that's the problem. Okay, that's interesting. Let me bring up another data set that actually has some interesting variations in it. We're not going to be able to explore many differences if we're just looking at data that's the same time. Oh, because I don't know why, because this is just a setup data. Yeah, okay, never mind. Forgot what this data was. Okay. So we want the runtime data, which actually shows us the runtime over time instead, right? So that one is this data set, population density dash runtime. Okay. Okay, there we go. So this will be more interesting. Sorry about that. False start. So this is the data where we recorded over time, right, how many people were infected and so forth, right? And so, for instance, one thing we might want to look at is the relationship between the number infected and the number of turtles infected and the step that occurred, right? So this would tell us on average, how many people, how related is the amount of time to the number of infections. It should be pretty related, right? Because of the fact that over time we know people become more infected. Right? And I should have really run the code that renames these, but let's do it this way, right? So as you can see, right, there is a correlation at 0.14825. Now, this isn't quite answering Jorge's question because Jorge was asking, how do I investigate the relationship between two data series that are collecting from two different groups? But once you get the data into R, it's the same no matter what, right? Like this could be red people and this could be blue people, right? And we're just looking at the relationship between them. But the real question is, what kind of investigation do you want? Let's see if Jorge has added anything else onto that. He hasn't yet. So that's the real question: is what kind of examination do you want? So here I'm just looking at how well correlated they are, right? I could also look at, for instance, the mean squared error between the two, which would tell you like how similar the two data series are to each other. And I could look at a bunch of other measures examining the difference between the two. I can't remember if mean squared error. No, it's not defined off the top of my head into R. But you can easily define it as just the distance between the two vectors, right? You can do whatever data series analysis you want. You just need to read the data in, make sure you're outputting the results correctly, and then you can do a bunch of pairwise comparisons between two series in the data, right? For instance, I could just look to see like how well does the time step predict the count turtles with infected. Now I'm going to regret not relabeling these names. Right. Okay. So this takes it one step beyond. With data. This takes it one step beyond correlation because it allows me to access an intercept as well, right? So this basically says that there's this basic intercept of 42, right? And that then the number of turtles that get infected every time step is about 0.075, so just less than 1/10 of the turtles get affected every time step, right? Now that's kind of interesting, right? Because we're only starting with one turtle infected off the bat, but that's because we're trying to fit a linear model to what's a nonlinear process, right? And so this is another way you could experiment about the relationship between two different time series that you have in your data set, right? So in this case, what I'm asking in linear model, I don't think we actually discussed this because that kind of goes beyond the scope of the class. This is really starting to get into R itself rather than NetLogo. But if you look, let me show you. You can always type into the help window to get the help about these different things. Okay. I don't know why I was asking me to save on that. Okay. So here's the help window for R on the linear model, right? So what this will do is this is basically a quick way of doing regression. And as you can see, right, it essentially allows you to take a formula and then automatically try and fit that formula with the best coefficients to the data, right? So here they have some examples, right, where they have two data sets and they're just trying to say how well is weight related to the group that is assigned to that group, right? And you can actually tell it to do it without the intercept as well by doing this -1 at the end. And what that is going to try and do is fit a straight line as much as possible between the two data sets, right? And gives you some example of what's going on. So, but as we know from playing around with the disease spread model, disease spread is a nonlinear phenomenon, and so we're trying to fit a linear model to a nonlinear phenomenon, which is not going to give us a good fit. In fact, we can actually, let me turn off the help for a second, right? We can actually look at the fit. I think it's summary will give us the fit, yeah. So we can do a summary of the model, right? And you can see that though both of the values are obviously significantly related, the R squared value is only about 0.02, right? Which is very low. And R squared of 0 indicates that there's almost no relationship between the input and output. And here it's just saying there's a small minor relationship. And that's because, again, we're trying to fit a straight line to a nonlinear model. But that's another way you could look at it. And actually, by the way, this actually answers a question that came up at the forum. Someone was asking about how to do multivariate analysis, right? So I can, since we've introduced linear models now and kind of talked a little bit about that, right? Let's go ahead and bring that up. That data set is the spatial data set they were asking specifically about. So one interesting way to do this, right, would be to think of your agent-based model as simply an experiment where the parameters are the inputs and the measure is the output. Now, in the particular example I just did to answer Jorge's question, I was actually looking at both outputs, the step measure and the number of trills infected as an output. But instead, for instance, just before I go to the disease model, right, I could, right, build a model that is based upon some of the input variables. So, for instance, this is the mobile model. So I have the number of initial infected, and I have the number of people. Now, those are going to be constant in this model, so I'm not going to be able to explore anything. But I could try. But if I had varied those parameters, see, actually, the number of people does change in this model. Yeah, but number infected is constant. If I remember correctly. Yeah. So I need two things with variance in order to explore the relationship, right? But I could, for instance, easily generate a linear model that was that looked at the relationship between the number infected. Let me see. I'll just bring that other one back up because I don't want to type number infected again. And the number of people, right? And this model, has a lower intercept and says that for every additional person, right, you're going to get the number of infected is going to go up. And really, in the end, what we're saying, because we're looking at the runtime, we're saying this can go up that much faster, right? It's not quite what we want to look at, right? Actually, probably what we want to look at is the final step, right? So let's actually do that instead. Do that becomes a little tricky. We actually want the other data set where we don't look at the runtime, right? So let's instead bring up the spread of disease data. Let me make sure I've got the right data set that has the spatial decay data in it. Hold on one second. Just trying to get it loaded up. Sorry, it's taking me a second here. Okay. Okay. So here's the data. Let's see, that's the file name. Let me load it up. Spread disease, population density. Nope, not that one. That's not the right one. It's this one. Okay. Okay. So this is the model that I ran where there was this density and decay variation, right? This has this interesting relationship between disease decay and the density, right? So if you look at it, right, I'm going to vary both the initial number of people right? And I'm also going to vary the disease decay, which was this geographic effect, right? And so I could ask the question, like I did using the 3D plot, right? What is the relationship between the disease decay and the time to infection, right? So the first thing I have to do for that is actually just get the final time to infection. Let me see if I can pull up that code I have for that real quick, right? It's a little bit tricky to actually just figure out from a random data set what the last time of infection is. So let me see if I can grab that quickly. There we go. Oh, here. I already have that code pulled up. So here I'm actually pulling up the code that I actually used in the model that's actually up on the website, right? And I'm going to aggregate over the multiple runs, right, so that I don't have to worry about having the fact that I have multiple run sets. And then I'm going to investigate, what's going on. And one of the things that I did, right, was create this three-dimensional plot, but instead, as I talk about, I could create a generalized linear model, right? And so this is the generalized linear model, right, that we just talked about. And in this case, I'm taking the mean of that time to infection, I'm regressing it on the number of people squared, the disease decay, and the disease decay squared, right? And this winds up getting, if I remember correctly, let's see, summary model, a fairly good fit to the data, right? Actually, one of the annoying things is that it doesn't actually present me with the easy to understand R squared value, but an AIC of 460 is fairly low. And in fact, but interestingly enough, the AIC, which is a measure of how well it fits, for the slightly simpler model is actually even better than the one for with all the factors involved, right? And so this is an example of how you can basically show the relationship between multiple data and the output. And so, yeah. So, Jorge, that was a little bit of a long-winded answer to your question. But essentially, the answer is that just rather than treating, number of people and disease decay, rather than thinking of them as kind of these, they have to be inputs, you could think of them as just data from different groups that you're analyzing. So I hope that's helpful in some way. Okay, let's see what else we got. So, oh, so Carol did have a follow-up question, by the way. So we were just talking about, let me turn on my camera. Okay. So Carol had a follow-up question. She asked about that special caret character in the Voronoi, and I did kind of skim over that really quickly, right? The caret is brand new. The arrow is brand new in NetLogo 6. Let me see if I can pull up my NetLogo window again, right? So you can see it. This one? Yeah, it is. Okay. So the arrow is brand new in NetLogo 6. What does the arrow do? Well, the arrow essentially, let me see, it's in the recolor procedure, right? No, it's in the setup procedure. So the arrow is what's known as an anonymous function. And so let me pull up, let me show you what the dictionary officially says about the arrow. And I'm actually going to have a special section in Unit 8 or 9 on the arrow because it is kind of a complex topic. So if you don't get what I'm about to say, hopefully you'll get it then, right? So the arrow creates and reports an anonymous procedure, a command or reporter, depending on the input. Within commands or reporter, the listed args may be used as you would use a let or a procedure, right? So essentially, the way you can think of it is it's saying, I'm going to give you an argument, and I want you to map it to some other argument, right? And that's based upon a command, right? So in our code, right, it's saying that when you create 140 values using this procedure, which maps end to end, right? And what does end to end do, right? Well, what end to end does is it's going to pull from the filter procedure on the previous one, which is this map the number 140, right, to mod mod 10 greater than or equal to 3 and mod 10 greater than less than or equal to 7. So it's going to only pull in these numbers that are between 3 and 7 that are between 0 and 140, right? So let's see, we'll go over here, right? Length of available colors, right, is 33, right? So what it's doing is it's running this filter command, and filter, of course, is a fairly complex command itself, right? Filter, pull that up, right? Filter basically takes a list and applies a filter to it and only returns the items for which that filter is true. So, for instance, if I take the filter is number and apply it to the list 1, 2, 3, 2 is in quotes, so it's not a number, so it only returns 1 and 3, right? If I do filter and I apply the I less than 3, it's only going to turn back numbers that are less than 3, right? Or S mapped to the first S not equal to T, right? Where it's going to return back high in everyone, but not there because there has a letter of 3, right? So in our case, in the model that we're looking at, the Voronoi model, right, how is filter being used? Well, filter is saying only give me the values between 0 and 140 in which the mod of 10 is greater than or equal to 3, right? And the mod is going to give me a remainder. So if I have 23 and I mod at 10, I get 3, right? If I have 22 and I mod at 10, I get 2, right? And it's less than or equal to 7. So if I have 23 and I mod at 10, I get 3, which is less than or equal to 7, right? So it's only going to return the numbers between 0 and 140 that fall within this range of 3 to 7, right? And it's then going to take that whole list and shuffle it, right? So anonymous procedures, like I said, they're a little tricky. We will talk about them more in the advanced NetLogo section when we start to talk about especially some of the other things. So hopefully that's helpful. Okay. So Kay Perrins asks, what are the links between agent-based modeling and Monte Carlo modeling? Your book doesn't mention Monte Carlo except once in a footnote to class. It should mention it more because NC is very common in many engines, whereas ABM is not so well known, I think. Yeah, for sure. So yeah, you know, you're right to some extent. Monte Carlo is very much what drives a lot of the simulation of agent-based modeling, right? Maybe we should mention it more, but our book does not assume that people know what Monte Carlo is either, so we don't want to confuse them by talking a lot about Monte Carlo methods when they may not know at all what Monte Carlo actually is, right? So we wanted to introduce it from a brand new standpoint. But yeah, Monte Carlo, for those of you who don't know, is this idea that one way you can start to estimate the property of something is by drawing a random variable of that number and then checking to see whether or not that random variable matches some truth that you want, right? You know, there's a lot of classic examples of like estimating the density of a circle by throwing points and then asking whether or not the point is in a circle and then calculating how many points are in the circle versus outside the circle, right? So it gives you an estimate of what this is, right? So imagine that I could, for instance, not be able to, like, I have a question as to whether a series of points has a high value, right? And I don't know, and I can't tell you all the points that have a high value, but I can tell you what the value of something is if you give me a point, right? So I can give you that point, that set of coordinates, right? And then you can tell me whether or not it is. Now I can estimate the density of what's going to happen. Or sorry, we got distracted by something. I can tell you the density of that object in that space, or how many points of high value there are, by just calculating the ratio between how often, if I generate random numbers, how often I see a high value point versus not a high value point, right? And that's that's the basics behind a lot of Monte Carlo methods. They're used in a lot of different techniques, and essentially, when you run a simulation multiple times, and then look at the means and the averages of those runs, you are in fact calculating. You're using Monte Carlo methods, right? That they're just called either. That's the term that's used in the field. Okay, Brents, the only reason why we didn't talk more about them is because we couldn't assume that you knew what Monte Carlo methods is. You say they're used a lot in engineering, but even within engineering, it's only a small space of engineering that they're actually used, right? And the textbook was kind of meant for people from science, from more natural sciences, from engineering, from public policy, from other areas as well, right? So it wasn't meant just for engineers, right? But yeah, you're completely true. We owe a little bit more to Monte Carlo methods than what we discussed. Okay. Let's see. One other quick question that came in at the end. Dia Putri asks, is it possible to contact you after the class because I'm going to run my model in the end of August? It is possible to contact me. I can't guarantee how much time I'll have to respond to new models, right, or anything like that. And of course, if you want to get your certificate or anything like that, you have to complete everything. You have to complete the model by August 13th. You have to complete the peer reviews by the end of August, and you have to complete all the tests by the end of August, right? So that's very important to do. Okay. I got some questions about, so I do all of my coding in this class in R using the Mac interface and just kind of using the traditional Mac R tool that you saw me just demonstrating, right? Were there examples where how about using other editors such as Jupyter or Anaconda or things like that? And of course, you're more than welcome to use those. There's nothing preventing you from doing that. Jupyter Hub has become really popular for doing this kind of analysis, and so I would highly recommend taking a little bit of look at some of those. Another question came up in the YouTube channel. So Carolina asked, could you mention examples of ABM applied in practice for making decision-making in social sciences? All the articles I read are applied. Ones are not really, or academic ones not really applied, though some of them have that as the school. Well, yeah, I mean, a lot of the work I do has the goal of actually making image-based modeling more applied, and we've tried to talk about that. But as you mentioned, a lot of my papers are fairly academic. They're talking about theory and interesting insights that we gain about the world, rather than talking about how to actually make a particular decision. There are companies out there that are using agent-based modeling very specifically to help make decision-making in social sciences. Two that I can name up off the top of my head are ThinkVine and Concentric. Right? They're both companies that apply agent-based modeling to helping organizations better understand their marketing issues, right? ThinkVine focuses mainly on the marketing mix type of question. Concentric focuses more on kind of an overall marketing strategy question. They're both great in that space. Another company that works in this space is Redfish, which I've mentioned a couple of times in some of my examples. They use agent-based modeling in combination with traffic planners, for instance, for trying to understand the effect of road closures. They do a lot of work with fire departments, right? Trying to understand how firefighting spreads, how wildfires spread and how you might combat them. And then there's been a ton of work in traffic and simulation modeling. I just looked for practical references to the TransSim package out of Germany, among other places, right, where agent-based modeling has been used to kind of understand traffic patterns and understand policy solutions to those. So those are some examples off the top of my head. I'm sure I could find many, many more for you if you're interested, but there's definitely a lot of examples of agent-based modeling being applied for actual practical decision-making. Okay. There were a bunch of questions about histograms in the forum, and the one thing that basically I want to remind everyone, right, is that you can't really do so before you ask NetLogo plots to plot something, right, you have to make sure the values are set. If the values aren't set before the plot happens, right, then you're going to run into problems. And the plots, on the automatic plots, the way they're set up, the reset ticks command causes them to plot. So let me show you this real quick. Now, this is kind of a common bug that occurs, so I think it's worth spending a couple of minutes on. Right? So let's turn on the NetLogo window again. Okay. Now I'm just going to go to a brand new model. And I'm going to say to setup, create 100, set, let's see, set wealth random 100. That's all my code does. Hit setup, I get my turtles. I probably want to add a clear all in there real quick. Right, and then I'm going to add my plot. And my plot is just going to be a histogram of wealth of turtles. And one thing you always want to do when you do a histogram is change from line mode to a bar mode because we're more used to seeing it that way, right? And I hit OK, right? So I can hit setup, and nothing happens. And why is nothing happening? Because I haven't hit reset ticks yet. So plots don't start until it sees the reset ticks, and then you get your plot, right? Now, here's the problem. If I haven't set that wealth area up beforehand, I'm going to get an error. So if I do the reset ticks before I set the wealth variable, right, it's not going to plot anything at all in this particular case. And in some cases, it may actually give me an error based upon what it's trying to plot in this case, right? So if, for instance, I had accidentally said, let's see, what's a way to do that? So let's say I'd created my 100 turtles. I'd set the wealth to an empty character on accident, right? And I'd set reset ticks. Right. Actually, that's still not giving me the error. Let me see if I do a tick, does that give me an error? No, okay. So sometimes, though, for some reason I can't get the exact error to regenerate right now. But sometimes you will get an error basically because you don't have the data in the right format. And you can't trust what format the data is in before you set it, right? There's no default value for a turtle. Well, there is, but you should assume that there's no default value for the property, right? So if I do set up like this and I hit go, it all works fine, right? But for instance, if I had the reset ticks up here, right, and when I type setup, there's nothing displayed. Of course, just as I say go, it does work, right? So just make sure, the big point I want to make out is make sure that your reset ticks is after whatever values you're going to plot have been set. Right? Small little point, but it's a common error that people run into. Okay. Quick question about final project types, right? What if we need to attach additional data to the project, like GIS files or PNG files? Just a little update. The course admins, Gabby in particular, is talking to the developers of the Complexity Explorer website to see if we can get added an additional file. So you can submit your NLogo file and then one additional file as well, which could be a PNG file or a GIS file of some sort, so that if you need that for your final model, it should be implemented. So we shouldn't be a problem. We don't want to be, accepting large file additions, but right now, we only are set up to set NetLogo. Finally, and I'll end here for the day. There are a couple other questions I haven't gotten to, but we're running out of time. There was a question about why all the extra spaces, right, in NetLogo, right? And that sometimes you can get away with it and sometimes you can't, right? Well, first of all, I would say that some of those spaces are due to what we call NetLogo Style. So it's very important to differentiate between style and syntax, right? So syntax is something you have to do to get the model to run correctly. Style is something that we encourage you to do because it makes the model easier to understand by someone else who knows the NetLogo style, right? When it comes to spaces, it also just makes the model easier to understand completely, right? So for instance, let's pull up our window again, right? If we take this model, right, which just does a simple plot of the turtle's wealth, we can remove a bunch of spaces in this model, right? We can remove all of this, right? And if we hit setup, it still works perfectly well. Well, it doesn't work perfectly well because the reset takes us in the wrong spot still. But it still works perfectly well, right? But the point, right, is that it's a lot harder to read when it's all packed up. Like, in fact, we can even remove more spaces from this, right? We can remove all these, right? Right, and it still works perfectly well. There are, though, certain spaces in NetLogo you can't remove. So in other programming languages, right, you often use the arguments to a function are inside of parentheses. That's not the case in NetLogo. In NetLogo, they're not. They're separated from the function names by a space. So for instance, if I remove the space between the CRT and the 100, and I try and hit move over, it's going to yell at me because CRT 100 is not defined. So that space is required, right? If I try to remove the space between set and wealth, it's going to yell at me because set wealth is not correct, right? Not defined. And so as much as possible, I would just recommend just stick with the standard NetLogo style, which is to put in all these excess spaces. It makes things a heck of a lot easier to read, right? And if anyone else is ever going to read your code, or if you're going to read your code 6 months from now, it's going to highly, highly, highly be helpful. In fact, you can also add in all the different comments, right? Creating wealth for the turtles, making it even easier for yourself. Okay. So that's all I have for today. Sorry, the part about I feel like the part about the R code today was a little bit rambling, but hopefully between that and the Unit 6 discussion, you'll be able to understand a little bit of what I was trying to explain about how once you get that data into R, it's all there. Where I was asking, how do I tell if there's a significant difference, right, between two different setups? There are a number of different ways to do that, right? You can kind of you can use correlation, right, to tell if it. You can look at the mean of the values and then the standard deviations and determine if the mean and the standard deviations are far enough apart from each other. And significant difference is something that is really dependent upon the field. So you should look to see what your field relies upon for telling if there's a significant difference, right? The kind of standard rule is if the two standard deviations don't overlap, you probably have a significant difference. But really, again, look to your field to tell what's going on. Yeah, so this week, working on Unit 7, verification, validation, replication. And we're also trying to finish up our model assignments. So hopefully that'll all go well. Thanks, everybody. See you next week.